Hey, what's up guys, my name is Cherno and welcome to episode 14 of the Sparky Game Engine series. So, last time we covered groups, and today we're going to finally begin our great and epic journey into texturing and textures by basically implementing image loading. So, in order to avoid the whole let's write a parser and decoder and decryptor, whatever you want to call it, for every image format in the world, we're going to go the route of actually downloading a library to help us with this. So the one that I'm going to use is something called FreeImage. Now, I've never used FreeImage before, which is going to be quite nice, I think, because it's as you guys wanted live videos and you wanted to see the entire process of engine development and whatnot, you're going to see me use something that I've never even used before, and I honestly haven't downloaded this before even, not to mention used it. So, but I'm told it's good, so we're going to basically try it out and see what happens. So this should be an interesting episode. But yeah, it seems pretty straightforward. I read a bit of the documentation. In fact, I'll probably have to download the documentation because I don't know how to use this. But I believe so the binary distribution. Okay, so apparently it's already built as well, which is good. So we don't have to build it ourselves, which will speed things up a bit. If we had to do that, that would probably be an entire episode on itself. And yes, if you look at who uses FreeImage, for example, you'll see that a few big things like Unity actually do use FreeImage. So this should be good. So let's just grab the binaries because that's going to be much faster. What is this? So what does this look like? Let's open this with, I guess, Reader. So this is probably really in-depth documentation. I think the examples will probably be better. So there are examples. So let's grab this FreeImage. Let's pop it into our documents and libs folder. And let's quickly just take a look at some of the examples. So we'll go, I guess, OpenGL. We are using OpenGL. Texture Manager. So let's open this with Sublime Text. Pop it over here and take a look at it, because that's what we do. Let's quickly bring up two columns, pop this over here. Alright, so it seems that, so there's FreeImage. Yes, okay, so nothing really here. Okay, here we go, load texture. So file name, text ID, okay, bunch of image format. Okay, so that's just OpenGL stuff. So FreeImage format, unknown. Okay, so they're, okay, unknown. Point to the image. Yes, so this stuff is generic, as you can see. I'm looking for stuff like file name. So file name, so we go fif, file image format equals FreeImage get file type. So first of all, this is a procedural library, it seems. Not that it matters. If it's still unknown, I guess, if still okay, so check the file signature and deduce its format. If it's still unknown, get it from the file extension. Okay, that makes sense. So it'll just read the .png part of the file name rather than the actual header of the file signature of the actual file. Cool. It'll, if it still can't find it, it'll just bail. We check if it supports reading, then I'm guessing we actually load it. So dib, what's dib? And bitmap, and what and bits at the point of it. Okay, cool. And then we get the bits from the dib, and the width and height from the dib, and that's it. So that honestly seems incredibly simple. So hopefully it is as simple as it seems, and we don't run into problems. And hopefully stuff like FIF supports reading will be true. Because I think we might have to download a bunch of plugins or something. I don't know, we'll see. But that looks pretty easy to me. So let's try this out. So we're going to literally try out this example. So if we get out of here, and all we're doing is we're trying this out now. So let's if 0, our main. And let's basically write a new main method that is just, or main function that's just going to test this out. We want to make sure we know how it works first and that it does work before we delve into actually implementing it into a texture class. So if we go into libs and FreeImage, so dist, I'm guessing. Okay, so we'll have what's wrapper? FreeImage.net. Okay, so this will do it for C#. Yep, Visual Studio 2005, fantastically old. Dist 32. Okay, so there we go. So this is all we need. We've got the header. We've got this is beautiful. This isn't so nice and simple. I'm really enjoying this so far. Let's go into our Sparky. So projects, Sparky, and dependencies, right? So we'll make a new folder called FreeImage. We'll pop this stuff into here. How do we have it set up? Okay, we had include and lib. So let's do that. So include. What's the shortcut for? I think it's Control-Shift-N. And why is this right-click taking so long? Why is Windows Explorer not responding? No, don't do that. Control-Shift-N. Yeah. Include lib and. Oh, why is my computer so slow? Look at this. Stop not responding. Probably because it has to add it into like Git or something. I blame TortoiseGit for that. Lib and bin. So into our binaries, we'll pop in the DLL. We'll put lib into lib and include. Okay, so everything's nice and organized now. So if we go to properties, and just in debug or whatever, we can go to our directories and add in FreeImage include. Okay. And in library, we can add in FreeImage lib. And that's it. Okay. So we'll probably have to add the DLL, it seems, because it doesn't seem like a static library at all, but we'll see. So let's begin. Let's include FreeImage. Let's copy most of this code. I'm just going to copy all of it, except for the texture parts. Okay, so test.png. We'll try PNG because that's probably mostly what I'll be using. Yeah. See, like everything looks pretty good. So let's. After this, we can just go print me my width and height at least. So width, height, and I'll maybe dump all the actual image data eventually. Let's just see if we can do width and height first. So let's go into like paint.net. Let's just make a quick 32 by 16. Let's not use powers of 2. Let's just make sure it can do that. I mean, it'd be pretty funny if it didn't, but that was a joke, by the way. Anyway, let's draw something like a gradient of red to white. No, that's terrible. Red to black. There we go. That looks nice. Let's save that into... where shall we put this? We'll put this into documents... project, Sparky core source. If we just put it into here, it should just add it into our executable. So if we call this test, doesn't matter. I mean, probably going to save it as 24-bit, I imagine. Maybe not. Doesn't matter. We'll go auto detect. Then we can maybe get the bits, but there we go. Let's test this out. So we'll go through this line by line because I don't think it will work. Okay. Well, we forgot to add the libs, lol, but yeah. And I should have some more faith probably, but okay. What's the lib called? No, FreeImage.lib. Who would have thought? That's simple. I like this library already. Yes. Okay, yep, it is a dynamic library. Get out. Stop it. Don't open 500 things, please. Let's go back into bin, grab FreeImage. So now we actually have, unfortunately, a real dependency in terms of it needs to be in here. We better put this in release as well. Build. Okay, so file name, good. Let's just initialize all this stuff. Cool. That's an old way of initializing variables, but okay. Well, it's not old, but it's different. Okay, so let's check the file signature. Did it work? PNG. Well, looks like it's reading our file okay since it got it from the header. Fantastic. I'm much more excited now because I think this is unbelievably simple if it worked. Supports reading. Oh yes, it does. Get bits. So yeah, we'll have to actually do that. Width and height, 32 by 20. Oh, it's just beautiful. It's just beautiful, and it just worked. Okay, let's do something. Let's just go through the bits. So what are bits? They're byte. So it's an unsigned char. Okay, yeah, so it's a byte. So for int I equals 0, I is less than width times height, I plus plus, let's just dump it. So bits I. Here we go. Uh-oh, it's going to just return. Okay, so it's just going to return us not exactly what we wanted. But so let's just cast them to an int. Let's see what we get. Okay, so that's each bit, right? So I mean 164, 92, 96 was the last one. Or maybe not. That's each byte, right? Okay, so first of all, it does look like it's in this is annoying. It does look like it's in the correct format, as in it might be BGR or something though. Let's do this. Can we work out the bits per pixel? We should be able to do something like that. So get that retrieves the actual image data, but is there a free image get channel? What does that do? Get, yeah, I want to see the get color type maybe. Free image color type. Let's take a look at the free image header. If we right click on this and go open document. So color type I think was a thing. So there's RGB. Yeah, that's not really what we want. What do we want? We want the type. Yeah, so the type is, but see the type is still a little bit annoying because that's the format. How can we get the actual, like, that looks promising, but it looks like there's just RGBA 16, which is different. Is it just normal int 16? Like, it's kind of annoying. Like, yes, it's one of these, but which one is it? So I would love to just find out what it is. Color channel. Yeah, see, that's a little bit annoying. There's probably a way to do it. I just haven't stumbled upon it yet, but weird. Yeah, these are all the functions. Okay, so I mean, let's just assume that it's in like bits. I really want to get the bits per channel. We need to get the bits per channel. That's really important. I might just Google this. How can I see the bits per channel? So this is typical development, by the way. This is not really helping either. Bits per pixel. That'll also work. But is that a thing? Bits. I don't want the conversion. Just tell me what it actually is. Let's go back up to the top. Oh, this is so annoying. Let's read through these again. Byte order, whatever, I don't care about that. Yeah, these are pretty standard, whatever. Yeah. So here's an enum which has this stuff in it. That's image format. Okay, free image type. Let's look at this example one more time. Let's unload it at the end as well, probably. Okay, so we get bits, which is just a bunch of bytes, which is just, again, the bunch of bytes is just unsigned chars, so they're one byte each. Because there's a type def for that. We get file type with support and reading, but I want my bits per channel. I want my bits per pixel. Bits per channel or bits per pixel. Well, if I had bits per channel, I probably need the channel as well. Not number of channels, but so free image type, where is that used? Here we go, get image type. Let's grab this. Get image type, dib. So let's see what this gives us. 1, okay. I'm guessing that's like the standard one. So if we go back to this and up to image type, 1 is bitmap. Gee, thanks. I'm just going to assume it's okay. We'll have to probably, I don't know. We'll revisit this some other episode. I'm hoping one of you guys will just leave a nice comment being like, oh, this is what you need to do to get the bits per pixel. But now that we have that knowledge, we can definitely say that well, first of all, width times height is probably not enough because it's in bits. So I assume that that would be correct. I don't know. Let's try this out. So bits I space that space that. So +2 +1. So this is assuming that it's RGB, not RGBA. But let's see what happens. 104 18471. Is that correct? No. This is a bit weird. See, unless there's alpha or something involved. Okay, well that's like, what color is that? If that's even right. Again, I have no idea what the format is, so it's a bit difficult to actually see. Okay, it's that. Okay, so it's probably just not read the image. So maybe it is 4 then. Let's try that. That's even weirder. 238, 254, 238. That's like white. I don't have that color anywhere. Okay, the example actually made it into an OpenGL texture. So let's see what this does. So, image format, huh? I should have probably just consulted this, to be honest. So we've got level, but isn't that all just passed in from here? Yes, it is. See, what if we don't know what the image format is? Can't we read it from the image? That's the whole point. Okay, let's, yes, whatever. So I kind of like this episode because it lets you probably see what's going on in my head, because this is the internal debate I'm having with myself, except I'm talking to myself here so that you can see what's going on. But how did it put it into OpenGL? Okay, it just gave it bits, and it was an unsigned byte, and it just gave it all the bits. Yes. And it relied on both the image format and the texture format. What if I don't know what it is, though? So right now it just did RGB and RGB. See, that's why this is annoying, because I have to kind of guess what the format is. So 104.184.71, is that it? Like, is there more? Bits. Bits. So let's take a look at this probably. Where's F12? Okay, it just says get bits. Any, well, actually, you know what? I do have the documentation, don't I? That's right here. What was it called? FreeImage get bits. No. Where's the actual... What? More, please. Oh, next. I have to click next. Phew. I thought they just didn't mention it or something. Returns a pointer to the data bits of the bitmap. It is up to you to interpret these bytes correctly. Thanks. Okay, according to the results of... Okay, here we go. Wait, BPP. Is that bits per pixel? Oh my goodness. I think I found it. Gimme. Just tell me where it is. There we go. Returns the size of 1 pixel. Oh, thank you. Thank you. Okay, it's just an unsigned... Unsigned what? Ah, it doesn't matter. Give me this. Give me all of it. Oh my goodness. Oh my goodness, thank you. I'm so glad I read the documentation. I don't even know what this returns. What's this? It's just a standard call. Okay. But, what? What in the fudge factory does that return? What the what? That is interesting. What? That I would expect, but... What in the... I don't know what that returns, but lol. Okay. Let's assume it returns an unsigned int or something. I might have to look at the source code or something, because they're not being nice. Let's take a look at what that even is. 24. There we go. So that's 24 bits per... Yeah, so it's 24-bit. Good. Fantastic. We've now got a way to do this. So, bits per pixel. So it is 24. Okay, that's good. So we probably shouldn't be printing this as an int, first of all, since they're... But the problem is I do want them to be printed... this is annoying. Let's quickly Google how to print char as hex. I mean, yeah, that'll do. I don't really want hex though. I just want to print it as a number. Can you go away? Like this thing? Can you go away? I don't want to do this. I can't. I've got another monitor there. Oh. Goodbye. Yes, that's simple, but no. I guess I could just printf it, but I wanted a cout way to do it. Cout print char as number. The plus. Okay, apparently. Because what we were doing before was we were reinterpreting them as ints, which means that unfortunately it loses its, like, since ints take up 4 bytes, it will most definitely corrupt everything because a char is just 1 byte. So this should hopefully work. That gave us the same stuff. Oh, I just don't trust this. Let's just print. Okay, but now we don't know if it's RGB or BGR. So that's the other thing. So let's just print it as essentially an integer. So bits I, and we'll just print the red channel apparently, or the blue channel, depends. 104. So is anything 104 over here? Nope. Ah, oh, what are we doing? 104. I mean, we would be at one point, but if it's 3, wait, bits. This is bytes, though. These are the bytes. So let's just do this. I'm giving up on this whole thing. Let's just do this. Let's just combine them all into a hex code. So hex equals bits I. We'll just assume that it's the red channel. We'll assume that's, yeah. This might be totally wrong, but we're going to have to trust it, and we'll print that out as hex. Because I might just be interpreting it wrong. So 68B847. That's not that at all. So what is it? I mean, we've got that color. That's the thing. It is kind of close. So it sounds like something we've got, like, somewhere along the line, but I don't understand why. It's like it's not going through all of them, but it should be. It should be. Because we're getting the width, we're getting the height, we're getting the amount per channel. So it seems like that should be correct if we've got 3 per channel, which we do because it's 24 bits per channel. And these bits are bytes, actually. They're not bits, they're bytes. I just, see, there's no way to check how many of them there actually are. That's a bit annoying, to be honest. Okay, we're paused over here. Let's just take a look at some of these things. 3220 bits per pixel for bits. Yeah, we all know that. This dib thing. PNG. File name is test.png. It's 24 bits. Let's make sure it's 24 bits. If we save this as test and we make it 24-bit, okay, just in case. I don't know. I mean, it's reading it at 24, so we still get that 68 thing. So That's so weird though. The other possibility is that it's in just a different format. Such as this one, but that's not really going to change anything. And in fact, that looks more wrong because that means it's 47 B8 68. I mean, it still looks like it's halfway through. This is ridiculous. Almost everything is pointing to this being 4. But I know it's not because it can't be. Yeah, that's most definitely wrong. I don't know. I honestly don't know. I might just try and give it to OpenGL and see what's up. Maybe I'm printing it wrong or something. I don't know. Maybe I'm just so tired that I just don't know what's going on, but it's yeah. It's certainly interesting. 68B847. So weird. Retrieve the image data. Before we go, one more thing I might do is actually can you please go away? I know I can switch between apps, just I don't need you telling me. Get out. Ugh. Still trying to teach me. Okay, so I see. That's why. That's why I didn't have a return type and whatnot. Anyway, return the pointer to the data bits of the bitmap. Okay, yep. Get red mask. Okay, so we should probably look at them as well. Oh, maybe it's not. Maybe it's less than 1 byte per channel. Or more. This is so complicated. Let's... okay, here we go. This is some reading magic. I don't know what that does. So... bits, yeah. So for height, for width, yeah, it's going to go through each of them. Bits plus equals pitch. Pitch, I'm guessing, is just what's pitch? Pitch, I'm guessing, is just get like the other thing. Okay. So one more thing we should. Okay. Oh, here we go. Let's try this. Lol. This is how people work out how to use libraries, by the way. In case you don't know. So let's try this. So pixel, I think this will just reinterpret everything. I should go back and look though. So they've got the pixel. Oh, they do that for apparently each Y though. I'm even more confused now. Weird. Pixel X, and then the pixel has, so we have dot red, dot green, dot blue. Okay. Red, dot green, dot blue. Okay, so let's try pixel I dot red okay, let's try what is this? What are you? Okay, you are a struct. So that should work, shouldn't it? It should, but it's not. An integral on scope. No, it doesn't have to. Oh well, yeah. Let's just bring this out. Red. Let's just print the red channel. Really looking forward to this working. Maybe. Lol. Can you go away? Maybe not. Apparently. Oh, this is... Okay, what was it? It was a float. Okay. Oh, well, maybe this means that. Nope, that's still sad. They were doing it every frame, which was a bit weird. I don't think that will make any difference. No. It can't. Zoom in a bit. So they're assigning it here for some reason. Oh, I see. That's why they're doing it, because they're going bits plus equals pitch. But it'd been good if they told me what pitch was, because... Oh, here it is. Get pitch. What the fudge is going on? This is the weirdest... This is the weirdest thing ever. Okay. Let's make this work. X, X, X. Okay, so pixel X plus Y times width. They're probably not even doing that though, are they? Well, they're just doing that, but I guess we can just do that. We'll print red, and then here they just go bits plus equals pitch. Pichu. Pitch. Oh, you're still ridiculous. Maybe I shouldn't be printing them or something. How is this even, like, working? I mean, they're assigning, it looks like they're assigning 128 to something that's a float. So, it's not in between 0 and... Oh, lol. Okay, this makes more sense. This is what I was doing before. Wait, that's if it's RGBF. This is getting annoying. Okay, so... let's ignore this. I probably should have read that first. Oh, you can move this. If image type is a fit bitmap, and if it's 24, okay, that's good. That's what we did, 24. Then we're going to go through, and pitch is still a thing, but let's just steal this real quick. Get rid of this. Whoa. Oh my goodness. I tried to steal it, but it didn't want to be stolen. Why do they have next line here? Weird. But okay. Alright. So. Everything's just the best, I think. We've already got that, though. But it's assigning it. Why? Why would you be assigning this? Like, are you checking it or something? Oh, man. Okay, let's bring back our little friend. Longest episode ever. This is what happens when Cherno doesn't know how to use the library. And uses it. Alright, ready? Is everyone ready? That did not sound good. Lol. What? Oh, is that because it was... not? What was that horrible sound, though? That horrible sound. It sounds like something's not working, but... 71. That's still not what I wanted, is it? Whoa. It was 71 over here somewhere. Did you see it? What the fudge factory is going on? This is really weird. I'm gonna have to probably study this overnight or something. What? The pitch is legit. So that's totally okay. I know. I mean, it looks like it. Next line, that goes into the next line. And then we get some kind of like problem, but I don't really see it as a problem. Like, it's a sound. It didn't happen that time. I don't know what's going on. 71, 184. That's what we were getting before, wasn't it? I'm pretty sure. I'm pretty sure it's what we were getting before. 71, 184, 104. That color is definitely in our image somewhere. You know what? Let's just try this. Probably should have done this a while back. Let's just change this. Let's make this like 8 by 8. And let's set it up with differing colors. This is probably a much better way to debug it. So we'll start with blue. We'll go to like that color. That color. We'll keep one red. We'll just make like a kind of rainbow thing. Oops. And we'll see what's up. 070, 183. Is that correct? No, it's not. So 183 is correct. So 070, 183. What? That's the top one. Suspicious. So it did 8 pixels of the top one. This better not be what I'm thinking. What the fudge? It did it in reverse order? Are you serious? Why? So it started here and read it like that. It seems. Yes, that's exactly what it did. I bet the first color is going to be this one. It is. We're done. Vroom.